Good morning, ladies and gentlemen. Welcome to Algebra II, Miss Quinn's classroom. This is section 1.1. First of all, we're going to start off with some vocabulary. For section 1.1, I'd like you to write down these 5 terms. A variable is a symbol that can be replaced by any member of a set of numbers. Basically, it's some symbol or letter that represents an unknown number or entity. An algebraic expression happens when numbers and variables are combined using arithmetic operations such as addition, subtraction, multiplication, division. An algebraic sentence happens when these expressions are related with a verb. We have an is equals to or a is less than, and it becomes a statement of equality. Now, an equation is a sentence stating that 2 expressions are equal, and we write that in mathematical form, and we connect that with an equal sign, not just an inequality. A formula is an equation showing the exact relationship of variables. And some good examples of these for an algebraic expression, a nice example might be 2 plus x. For an algebraic sentence, I might say 2 more than x. And then here I'm not quite done because I need a verb. So I might say is equal to 10. An equation, I could write this sentence as an equation. I would have 2 more than x. So x plus 2 is equal to 10. And finally, a formula that we're all familiar with might be the formula for area of a triangle. 1/2 base times height. And this is the terminology we're going to use for this section. For a warm-up, let's go ahead and write each phrase or sentence utilizing symbols. Whenever we see a number, that's where we want to begin. So first I look at a number, and I want twice that. So I'm thinking about what arithmetic operation gives me twice something. And it's definitely multiplication. I get 2 times x. Number 2 here, 2 less than a number. Again, I start with my a number. And let's use a different variable this time. How about n? And I want 2 less than n. So what arithmetic operation gives me less than something? That is subtraction. So I have n minus 2. How about this sentence? 2 is less than a number. Please notice that here we have a verb that was not in these first 2 phrases. This becomes a sentence. 2 is less than a number. So I have my a number and my 2, and it's less than, so I'm going to need to connect them with a less than symbol. Remember from grade school that the bigger side eats the bigger object. Cheesy but true. All right, let's look at number 4. How about 2 is greater than or equal to a number? I'm going to look at my a number, and I'm going to look at 2. And I want to represent that 2 is greater than or equal to. So now I'm going to utilize my inequality with equality statement. Finally, number 5. A number is approximately equal to 2. Here we have another verb. Now let's use a different variable for this time. Let's say q is approximately equal to 2. Now again, I have my 2, and the approximately equal sign is kind of like an equal sign with a squiggle. All right, now let's move into some examples, now that we've got our warm-up done. If we want to express the cost of W pencils at B cents per pencil, that will simply be W pencils B times. And if we write that out algebraically, when I multiply 2 variables together, I can simply write WB. That means W times B or WB times. Alan has $75 in the bank. He's going to save $25 each month. How much money, excluding interest, will he have in the bank after M months? Well, he begins with 75 and he saves 25. So if he is going to continue adding to his bank account, we want to use that addition symbol. And I want to add 25, not just one time, but M times. And I would represent that by 25 times M. Now this expression shows how much money he has after any month. If I want to find out how much money he has after 10 months, I can simply plug in 10 for M and find that exact value. Now let's look at the number 3, and the formula for the volume of a sphere is 4/3 pi r cubed. And if we're going to use that to find the volume of a ball that's 10 centimeters in diameter, first of all, we're going to need to be able to recognize that pi is approximately, I should probably use those squiggle symbols, 3.14. And to find the radius, which is also in my equation, I need to find it from the diameter. Hopefully you remember that radius is 1/2 the diameter. In fact, if I drew you a little circle up here, let's say this is a nice sphere, the radius only goes halfway across, where the diameter goes all the way across. Now that I know pi and my radius, first I'm going to find the volume in an exact form, and then we're going to simplify to find it in an approximate form. Let's plug in here 4/3 pi, r is 5, cubed. And technically, because 3 is in the denominator, it's the only thing in the denominator. So I'm going to show that at this point. When I cube 125, when I cube 5, I get 125. And when I multiply that by 4, I get 500. Go ahead and plug that into your calculator and make sure that you agree with me. At this point, this is our exact solution. To find the approximate solution, we would plug in a value for pi. And I'm going to go ahead and let you simplify that on your own. Either utilize your pi symbol on your calculator or 3.14. Now for tomorrow, I want one sheet to turn in at the beginning of class that answers these 2 questions. Number 1, I want you to write this sentence as an equation. 3 less than a number is 10. And I'd also like for number 2 to know what kind of device you watched this video on. Was it a cell phone? Was it as a computer? And how easy was that to download? Thank you so much. I'll see you in the morning.